Hello. In this video, you're going to get 4 examples of Lewis dot structures. I chose them strategically to give you kind of 4 sort of different things. We have oxygen difluoride, OF2. We have ammonia, NH3. We have the diatomic oxygen molecule, O2, and the diatomic nitrogen model, N2. And I'll sort of talk you through them, and we'll see how it goes. So I'm going to wipe this, and we'll start working through. First one I mentioned was OF2, which we'll call oxygen difluoride. Nice. So, plan here is to do the Lewis dot structure. First thing we want to do is write the atoms down that we're going to be working with. Oxygen, 2 fluorines. I arrange the oxygen here in the middle and the fluorines around the side. Usually when we have a formula that has 1 of one thing and 2 of another, we're going to put that single atom in the middle and arrange the others around it. So that's what I did. Okay, so the next step is going to be to put valence electrons on. Fluorine is in group 7, therefore there's 7 valence electrons, so I'll do that. 7 dots. I know oxygen to have 6 valence electrons, it's in group 6, so there's its 6 valence electrons. Now that I've got my valence electrons placed, I'm going to start doing bonds. Remember, we want to take 1 off of each of the substances, 1 electron off of each of the substances that are going to be bonded, and those 2 electrons are going to become a bond. Remember that bond counts for both the fluorine and the oxygen over here, so both of them. So let's see, the fluorine now has 2, 4, 6, 8 valence electrons, and the oxygen has 2, 4, 6, 7 valence electrons. So the fluorine is done. The oxygen needs some more work. But we have this other fluorine over here, so let's check that out. Let's form a single bond between oxygen and fluorine over here. And so we took 1 electron off of each, and those become the shared bond. Now, this fluorine has 2, 4, 6, 8 valence electrons. And the oxygen now has its full 2, 4, 6, 8. That includes the 2 bonds. So fluorine is all set with 8, and now oxygen is all set with 8. They all obey the octet rule. This would be a Lewis dot structure for oxygen difluoride. Now, the question I want to bring up in your mind, and we'll answer this a little later in class, is this the right shape? Oxygen is going to have to be in the middle, and fluorine is going to have to be attached to either side, but is this the best way to represent it? You're going to find out a little later that it's not, but we're going to leave it like this for now. So there's oxygen difluoride. Then I believe the next one I gave you was ammonia, NH3. So this guy is ammonia. Ammonia, you may know its smell. It's in a lot of cleaning products. Tends to be rather pungent. So that's a nitrogen and 3 hydrogens. So I'm going to put my nitrogen in the middle. It's the only nitrogen we have. I'm going to arrange the hydrogens around the side. Nitrogen obeys the octet rule in that it wants 8 valence electrons, but hydrogen does not. It only needs 2. So let's put valence electrons on. Hydrogen has 1, it's in group 1, and nitrogen has 5, it is in group 5. So there that is, and I'm just going to start making bonds. We'll put a bond in here. So I took electrons off of both and put the bond in. Put a bond in here, and I'll put a bond in here. Working rather quickly. Now we see that each hydrogen has 2 valence electrons, and remember that's key for hydrogen, that they have 2, and this nitrogen has 2, 4, 6, 8 valence electrons. So it's all set, it has 8, it's all set. That's going to be the Lewis dot structure for ammonia. Continuing on. Now we get to O2. O2. That's going to be oxygen gas. Oxygen actually exists in the atmosphere bonded to itself. So there's just going to be simply 2 oxygens. Now, each oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So we'll set them up. And just as before, we're going to start bonding. I'll take this one off of here, this one off of here, and I'm going to put a single bond. Let's count. At this point, each oxygen has 2, 4, 6, 7 valence electrons. Same is true of this other one over here. So something's not there yet. Neither one of these oxygens has enough valence electrons. So instead of having just 7, what we can do is add another bond. This is called a double bond. I took 1 electron off of each, and I add another bond here. So if you look at this now, each oxygen has 2, 4, 6, 8 valence electrons. So with each having 8 valence electrons, that's all set. We have the double bond. Last one. Last one we're going to do is diatomic nitrogen, nitrogen gas. Nitrogen in the air is usually bonded to itself, N2. So let's see what that looks like. We have one N and another N. We know that nitrogen has 5 valence electrons. So now that it's got its valence electrons, let's start forming bonds. I'll start here, taking 1 off of each and putting in the bar. Now, each one of these has 2, 4, 5, 6 valence electrons. So it's not there yet. They both have 6. Make sure you see that. The next thing I'm going to do is just add another bond, just like with the double bond. I said, okay, what if I just add another bond to it? Let's count up again. It's going to be 2, 4, 6, and one more is 7. So we're close, but we're not quite there. So the next step, hopefully it's making sense to you, is I'm going to put another bond on. I'm going to take 1 more electron off of each nitrogen and compose a triple bond. So with the triple bond, between these two there's 6 shared electrons. That counts for both. And each one also has an additional 2. That means they both have 8. So this nitrogen has 8, this nitrogen has 8. 2, 4, 6, and then 8. So here we have the octets filled, and we see the existence of the triple bond. So nitrogen with a triple bond. So that's that. That's 4 examples that include double and triple bonds. Good luck.